happy to announce the first afternoon session, which is again about code because today is the Developers Day. And so we are expecting a few new insights now by Hugues from eShard about the really playing with somebody else's code so that hopefully it will be more secure afterwards.
Can you hear me? Yeah? Good. I think each time I had to make a talk in a conference, each time I have the slot after the lunch. It's a bit like I have a mission in my life to make it as entertaining as possible. So I will do my best, I promise. Okay, so I am Hugues Thiebeauld, and I am the CEO and founder of eShard. So at eShard, what we do is we try to very much look into the mobile and the mobile application security to make them more secure. Okay? To very much understand the threat and make them more secure. And there is a question that we have been having, and I would like to share this question with you today. And this is the purpose of my talk. So the question is all about mobile application security. So first, why do we need security in a mobile application? One, because it is doing something secure, like encryption, authentication. You can find a lot of different IDs for this. Or because the mobile application is having something secure. So it could be an encryption key, but it can be as well the code itself. Because you don't want the code to be duplicated easily because you spend a lot of time to code it. Okay, so you want application. You want security in your mobile application. How do you do it to make it difficult for a hacker to go through your application? I think this morning we had a very interesting talk about how your code can be exposed with the various techniques like static, dynamic analysis. And a strong way to protect your code, apart from, I would say, coding it properly, is to add software hardening, such as obfuscation or what I name runtime security protections. And the question I have today is, how confident are you that your software hardening is effective? Okay? So, if I ask the question differently, is how tough will it be for a hacker to go through my binary? Okay? So let's see, let's try to answer this question today. So you may tell me, there are plenty of tools out there doing some very nice vulnerability analysis of mobile applications. And it's using as input the binary. So here I put some example. I'm sorry if all of them are not there, but Now Secure, Fortify, Polio are all claiming that they are doing some vulnerability analysis. That's true. But they are doing vulnerability analysis. They are looking for weird behavior. They are looking for malware. But are they answering my question about the obfuscation, about the runtime kind of protections? No. Actually, for these tools, the obfuscation, the device binding, the anti-tampering are all a pain for these tools. Because it makes their work difficult. On my side, what I would like to is to focus on this. I don't care about the man. I would like to know if the armor is thick, is strong enough, as I would like this to be. Okay? So I first put this picture, but I should have put this picture. I think it's more Android Security Symposium. But the concept is the same. How thick is my shield? Okay. So one thing is I would like to separate security protection in two families. The one that the tools I was mentioning beforehand are doing, I name it behavioral analysis. You have to make sure that the behavior is appropriate. Okay? And I think it's important when you secure a mobile application. But on my side, the software hardening, per nature, is absolutely transparent from a functional point of view. And a good practice in development is when you want something, when you want to code something or to apply something on your code, it's good to have a test against it, right? But if it's per nature transparent, how do you do it? The second thing is obfuscation is not a black and white. We could even make a movie of the 50 shades of obfuscation, right? Thing is, it's not, is it obfuscated or not? You can obfuscate at different level. You can obfuscate different things, the codes, the symbols, the strings, whatever. So only obfuscation, we are talking about a lot of granularity. And when you want to apply a mobile application, some software hardening in your mobile application, you want it at a certain level, right? So you need to know about this granularity. So when you are a security analyst, like a laboratory doing a HE, so a mobile payment security evaluations, I think you have some people from UL today on the writer's laboratory. It's their day-to-day job. What they do is they take the binary and they have no choice of doing a manual inspection. Okay? So how does the manual inspection look like? It looks like this. So you apply the techniques that we had this morning. You take the binary, and then you disassemble, you decompile, you have tools for this, and you end up with this. So now you have two scenarios. You have the lucky one and the non-lucky one. So I will start with the lucky one. The lucky one is you are in a white box situation. In other words, you know the code. So you know the code, and you know you have the corresponding binary. And you want to check if the software hardening has been appropriately implemented or applied to the binary. So you have the chance of, I know where to look at. Even that, it's quite painful, but at least you have a lead. It takes some time, but this is not like the black box. The black box is someone gives you the binary. Binary is megabytes of data. And you have to start the work from this. Okay, so it's time for you to work and to take some time. Because one, you don't know where to look at. So you have to understand what it is doing. Imagine that it is obfuscated. It will take you time to have a look into it. It will be necessarily non-comprehensive. You cannot check everything. You won't be able to check everything. It's impossible. It's tedious and a bit boring. Right? So if I can be just a bit blunt, I would say that this approach is non-effective. And I can speak because in Ishard, we are doing this kind of analysis. And we know the pain that it can be sometimes. So we try to find another way, a better way. And this better way will use some automation. But when we were thinking about how we could apply a better way, we're giving this requirement to us. Comprehensiveness is one of the top requirements. Why being partial when we can be comprehensive? We wanted it very visual. Why? Because when it's too verbose, it's difficult. The eyes is a fantastic tool for a security analyst. We'll see how it looks like. And we wanted this easy to use. I will say why afterwards. And we didn't want a tool saying, yes, it is secure, or no, it's not secure. Everyone is asking for this. But I'm sorry, as a security expert today, I cannot answer this question. I can tell you if there is some level of protections, but you, the one creating the mobile application, has to know what kind of security level he wants. I cannot decide for him. So this is not a black and white. So how does it look? How does it look like? It looks like this. So just in Google Chrome for this, and we simply take as an input the APK. Okay? So APK, you can just upload it. So here we have a bunch of APK. So you upload the APK, and then we will process APK. So we will automate. Here we are automating the decompilation, the disassembly. But what we do after that, and we take all the piece of code, and we will analyze the code. For each piece of code, we will apply a set of heuristics. So the question is not to claim that the obfuscation is from ProGuard or Arxan or whoever you want. This one is not interesting. This is signature. This would be signature-based, but it can be circumvented very easily. Now, the idea here is to apply a set of heuristics. So we follow up the heuristic, and each heuristic will target some specific obfuscation. And the outcome of it is this. So on the left, you have your list of APKs, the ones that where the analysis is done. Here in the middle, you have this visual view I was talking about. So this graphical view gives you a full overview of your binary, and each tile, it's a piece of code. You have colors. I will talk about the colors afterwards. And on the right, you have the binary, but in the tree file. The exact input that you had previously in my example. So you have all the piece of code. So how can you work with this? But first, as you can see, there are colors. Each tile has been processed with the same heuristics, and each time the heuristic gave like, I found something, or I didn't find anything. Okay? So after that, when you move your mouse on it, you have the kind of information of how much we found into it. So as you can see here, we put 100% of obfuscation. Doesn't mean that it is obfuscated as a maximum. It means that where we found the most obfuscation in the binary is this 100%. And you can compare for the rest. Look at this graphical view, how much the different pieces of code were differently handled. It's amazing. So the darker the tile, the more obfuscation into it. Okay? So after that, you cannot stop your analysis here, right? But, so what you can do is you just click on the tile, and then you will jump to the corresponding piece of code. Here we go. So you have this tab on top, so you can very much jump from the graphical view to the code and vice versa. So as an example here, we can see that the string that will be highlighted, the string has been obfuscated. And there are some other obfuscation, but it's just an example. So it's obfuscated with non-ASCII characters. Okay, this is why a heuristic said there is something to it. Well, this one is very easy, simple example. It shows you how it works. Okay, so we look at the codes, the symbols, the names, and so on. And each time, you can go on the right and see where is the corresponding file. So this corresponding file is highlighted with, okay, here. And you can very much jump from one world to the other and make your analysis in an effective way. And when you select a file on the right, you will have the corresponding the corresponding tile that will be highlighted in blue. Okay? So you know where it is located into the binary. So when we use this tool to do our analysis, what we try to do is to look at specific area in the binary, specific packages, specific libraries, whatever you want to name it. And you want to maybe to have a specific look at it. So what you do is with the tool, you can, here if you don't know which package it belongs to, you go on top and you see the name of the package. Okay? And when you know the package, you just have to go to the corresponding folder. This is what we do here. So you go to the corresponding folder, and clicking on the folder will just simply tells you where the tiles are within the folder. And you can very much move up and down into your analysis in order to focus on a specific part or having a broader look at it. And we found it extremely useful and efficient to work like this. Another feature that we found, okay, this one that shows a package that would have this some obfuscation, and obviously there is no obfuscation. Okay. So one other thing that we found useful, and it's pretty obvious, but is to use a search engine. Okay. So the search engine is on top right. Okay. And when you want to look at a specific functions or specific names, but you just type it. Okay, here is a banking application. As you can see, you type payment, and you have all the file, and you can very much look at them specifically. And after that, identify where they are in the graphical view, and how many of them you have in the tile, in the tree file view. Okay, so you can play and see what are the keywords you can find in the application. And the less obfuscated the application, the more grip you will have into it, obviously. Okay. So when you have to look into a mobile application like we do now, there is another thing that is extremely useful, and particularly to understand what the application is doing. There are the strings. The strings is a bit the sweet of the secure analyst. So this is why we took a particular care to look at the string. So you have a tab, strings, dedicated one, where we gathered all the information we could get about the strings. And you can very much look at it and see what are the strings obfuscated and what are the strings that have not been obfuscated. And you may find some sensible way to look at it and understand what the application is doing, how it works. So if I go back to my presentation, I would like to show you how it can be used. So I would like to show you two examples. So I think we will have a talk about a banking application in Poland. So here we played with some other banking application. I would like to show you how much differences you can find between one good application and one not as good as the first one. So first, the graphical things. So here you have an example of one or the other. Look at this. We cannot, obviously this is not the same developer here, right? It's impossible. So let's have a look at how we work on it. So first, you take this first example. I'm not going to do an in-depth security analysis. I don't have the time for this today. But you can see that it's spread, okay? Interestingly, you have these three lines, these three rows, so in the middle. Here, when it's about banking application, normally I have is always the same, is GMS, Google Mobile Services, that is more obfuscated than the rest. So this is the case here. But when you look at the rest, the level of obfuscation is not great. It's very spread. looking at the strings, so the string tabs, we could see that none of them were obfuscated. Only the names of the files were obfuscated, but the renaming was not very strong. Okay? So we could very much look into the code and actually put our grips and analyze it. You take the second example, much neater job. Looking into it, I won't say that it's a perfect obfuscation, but at least everything was renamed in a proper way. All the sensitive strings were obfuscated, renamed if you want, and they were encoded as well. So they were non-sensible, so we couldn't understand properly what they were related to. And generally speaking, I would say the job for hacker for this one, we could say that it's more difficult than the previous one. As a side effect, because there is always a side effect of security, I find it interesting as a security expert. This one is poorly obfuscated, right? But there is no structure, there is nothing. I don't know where to look at when I see the graphical view, right? Where to go? Maybe I can go to the Google mobile services. Apart from it, there is nothing that jumped to my eyes. When you look at this, the second one, neat job, we can see that attention has been taken on specific parts. But this is where I want to look at, to be fair. So it's telling me where to look at. So this is a bit the downside of the security. So I am not saying that it should not be obfuscated. I'm saying that security has to be, there is always a downside, and you need to be aware of this. Okay. A second thing that we found it's useful with this graphical view is the versioning. Because when it's about releasing a mobile application with some security into it, the versioning is a nightmare. You can do your manual inspection, or you can use this tool and you can do a proper check on, let's say, the version 3.6.6. But next week you will have the .7. And after that, the 8, the 9, the 10. Are you about to do the manual inspection or this kind of analysis each time? No, nobody does that. So you go and you say, okay, that should be fine. But you cannot build a confidence model here. At least with this visual view, it's very quick. You put it into the tool and you can see if it looks the same. It should look the same. It should. But at least you gain a good level of confidence how much it changed from one version to the other. And if you see that some critical parts have changed, it can trigger an action of looking deeper into it. So you have this insight. So I will stop my talk by this. Is this new approach with a first level of automation, and after that, as a security analyst, you can go more in depth, is very important. Why? Because we do believe that as security analysts, you will find that you go straight to the point. You have this global overview that brings you to the right level of information to start your analysis, where you are good at. And this comprehensiveness is something quite important, because you have at least covered the whole thing. But we didn't want to only target this new approach to the security analyst. Because in Ishard, we do believe that something is very important when building the right security, is to avoid the split between the expert and the non-expert. Why? Because it doesn't help. Nobody understands each other. So how to, I would say, show the value of what has been done when protection has been done by security analyst or security expert, we wanted to give away to other people, non-experts, but aware people, how much they can get insight into it. So maybe non-expert people won't do the in-depth security analysis. But with this first level of information, they get a lot of things that help them to understand what's going on in there. It helps them as well to reach a certain level of benchmark. Why? Because the automation is agnostic. You won't have a different outcome depending on the security analyst here. So you have a kind of general benchmark. And we do believe that it's very important to have, let's say, a reproducible process in place. And this is what we wanted to achieve here with this new way of working and looking at mobile application security. Thank you for your attention.
Thanks a lot for that in-depth view in the current version of the tool. Are there specific questions at the moment?
Is that ES Checker tool a tool that's available offline, or will these apps be checked and analyzed on your servers?
Now, today what we are considering is you can have it on your own desktop or laptop, so offline. We are just wondering if this makes sense to have it on a SaaS model, but it's purely a way to deploy it, but it doesn't need to be online to work. It can work in a standalone way. So it's pretty much up to the people needing this tool to tell us what they need.
Hello. Here, so far as I understood here, that you're basically showing the DEX information from the APK which you can get. So the strings, the methods, whatever. How do you deal with the APKs which are not only obfuscated, but are, for example, packed and protected on the native level? I mean, it's coming right now more and more often that the, let's say, not the only benign applications are using these kinds of protections, but the malware as well, and how you're going to analyze that with this tool.
I think this kind of tool has to live with the protection that they will have to face. It will have to face. So what I mean is, each time there is a difficulty, we'll have to see a way to overcome it. It's a bit like the heuristic we put in place. Can I say that they are exhaustive today? They are never going to be exhaustive. So it will be a constant work for this. But there is always a way to analyze the binary from here. We started with a static. You will see that there will be some other version in the future more targeting the dynamic. But there is always a way to analyze. And we have to face a different level of protections.
Thanks.
I have question, technical, several questions. So
Yes.
each block on this picture,
Yes.
what does it represent?
A piece of code, so a class, a method. When you compile and disassemble, you have all this piece of code.
Yeah, like basic block, method, class.
Exact.
So is it basic block actually, or
Is it what?
method,
Sorry?
basic block, like
Yeah.
control flow part, or I don't know.
After your phase of the compilation and disassembly, it's basically you have the structure of the binary in different chunks, and we take the smallest chunk we can each time.
Okay. How do you assess the obfuscation level? For instance, if I write my, I don't know, class name, not in the right name, but I name my class like A and method B.
Yeah.
In your representation, will it be like obfuscation without even running ProGuard or DexGuard?
It's all related to the heuristic we have in place. The heuristic will target specific obfuscation or specific way to name functions, to name, to code the symbols, to write, to name a string. Okay.
Yeah, like for instance, if I write my, I don't know, string in Russian.
Yes.
Will it recognize that there is obfuscation or not? In the string inside, like, or English version?
Okay, that's a good question. I think for the Russian, I will ask for the guy in charge of the heuristic, because I don't want to give you an answer. But yes, the heuristic has to be properly built. So basically, if when applying the tool to a Rutian based, and if we see that the strings is actually in Rutian and the heuristic has been poorly considering this, but we'll have to update the heuristic. This will be a constant work to make sure that the heuristic are in line with real obfuscation. So here, I don't know if I was clear, is for me it's very important to understand that this tool will have to live with the state of the art of the protection. I'm not saying that what it is today is covering everything now in the future. And depending on the nature of the heuristic, where we'll put some more and more sophisticated model behind this, we will have to make sure that proper level of information is processed.
Okay, thank you. And the last question about the comparison.
Mm-hmm.
So from my experience, it's very difficult to definitely identify between the versions which parts have been changed
Yes.
or have been not. So for instance, if you know about this tool I saw in the presentation, AndroGuard. So basically in the AndroGuard you have this specific functionality to compare two versions of applications and find out what is the difference.
Yes.
But it deals only with representation of different functionality, making it as a string, and then comparison.
Yeah.
So do you use the same approach?
Here, I think this one is still in the pipeline. Okay, but what we are about to code is a comparison that will use the shape or the graphical view. Okay, and we will be able to look if this shape of red and white is still the same from one version to the other, and say, okay, this one looks the same, or this one is different, and to help the user to highlight where the differences will be. Okay?
You're not talking about the representation, I'm talking about how you will identify these differences. So it's not that easy to identify differences. What has been changed in the code?
Yes.
So just I was curious about what method do you use to see the differences? Most probably this is, you mentioned this AndroGuard tool and you use the same thing.
I'm not sure. I would say, I know exactly what the team will do here for this specific part, so I don't want to come with the wrong answer. But, yeah, I prefer to not give you a wrong answer here.
Okay, thank
I
you.
would more refer to my technical experts for this.
Yeah, maybe I will come to you. And
Yes, please, feel free to contact us for this. Yeah.
thank you.
Hi, so I have a question. You said that, I mean, your tool pretty much relies on checking what kind of obfuscation is used
Yes.
to determine how secure the application is. So do you have any idea of what are the most common kinds of obfuscation that you see in the applications that you pass through your tool?
What kind of, sorry?
So I mean, there are different kinds of obfuscation mechanisms. So which ones are the most common ones among the Android applications?
So today, as you could see, we are focusing mostly on the Java part. Okay, so the native part is not yet available on the tool, and on the Java part, I would say ProGuard is the one we have spotted the most. Is it answering to your question?
Yes, we can also take it offline. Thank you.
Yeah. Okay.
Thanks again for your presentation.